And Kevin Cole, PM Head of Cloud Management Solutions at Supermicro, continuing our podcast on building out the infrastructure for a Neo Cloud. In the previous videos, we focused on a few things. Number one, we were able to show you the relationship between leaf and spine of Supermicro switches, how we plumbed out VLANs and presented those VLANs to appropriate physical hosts that were part of the Kubernetes cluster of a various shard and their corresponding VLAN on the leaf switch. I showed you how we passed over those VLANs between a leaf and spine switch on the .1Q trunk of its uplinks. And then also got into discussions about how we configured bridges associated with those physical hosts that were part of that Kubernetes cluster, and creating that electrical attachment between the VNIC and the vPort so that your virtual machines, when they get instantiated, could utilize and be serviced from those physical computes that part of that Kubernetes cluster that were attached back to the control plane of GeoWest shard. And then we also talked about the significance and importance of building in a OpenSense WireGuard server that has multiple NICs and how it actually does network address translation between the allocated floating IPs of each of the shard subnets and how they actually get funneled through the NAT interface of the physical server. And then we also actually built firewall rules and policies to allow that traffic to be inbound and out of bound. And we talked a little bit about the VPN setup that we're working with our friends at IT to be able to provide that ability for you to come in and take a look at the NeoCloud experience that we provided to our customer demo uh, environment. So we built a world-class lab here, and we're continuing to optimize and make it better so that our customer experience is going to be top-notch. All right, so enough of the discussion points and babbling about what we did in previous videos. Let's dig into the next phase and last phase of really proving that those virtual machines can get out inbound or outbound to the internet. So I'm going to log in here two ways into our control plane, the SDX control plane or Super Developer Console. The first one is through admin access. We talked about how you would log in using the default password here in previous videos, so I'm not going to get into that discussion. There is a great video of showing you how to install essentially the control plane of SDX. This is more from the standpoint of the user GUI and being able to navigate through the GUI. So we're not going to get into those details. If you're interested in that, I would suggest you look at the other YouTube content that's out here to be able to walk you through that particular use case. So we're going to do something a little different here. Instead of focusing on the GeoWest cloud that we've been focusing on, we'll just actually demonstrate to you the cluster north shard or the north shard. And again, that is in the VLAN 900 range of subnets. So again, here 900, 901, 902, 903, they're pretty much the same of how we built out from a control perspective. They just have different subnets and floating IPs and different bridges configured on their corresponding shards. So we're going to log in into the north particular console here. And so we're logged in as admin over here. We're going to log in as default here. And of course, you can come in through LDAP and import those in, but we're going to do something very simple here of using the default account to log in. I'm a little lazy here. So you can see here that this particular control plane is serviced by the cluster North Kubernetes. And so let's go back to the admin and just review that quickly so you get a sense in context here. So you can see here we have Kubernetes compute 1, 2, and 3, and 1, 1, 2, and 3. Compute 1 is the master node, and 2 and 3 are the workers. You can see their corresponding physical IP addresses inbound here, and various different types of core that each of these have. And in this use case, we're going to instantiate and test virtual machines, right? And there are no GPUs here, so of course we can't basically deploy containers, right? Because there's no GPUs to be able to do that. So we're going to use the use case of a simple virtual machine deployment to show you the power of the control plane as well, and test it to make sure it's working properly through our Neo Cloud setup here. All right. So I'm going to go to flavors. There's all kinds of flavors here that we've actually configured for this particular host. Again, flavors are configured by the admin and associated with projects. And so that's to set the multi-tenant cloud setup associated with a control plane. User management, we have a couple here set up too as well for LDAP. You can see here I have an LDAP user of Culp K that I could come in. I just chose to come in as default. We get into the particulars of how you set up the LDAP and things like that in other videos. So you can take a look at that if you like. Um, and let's dig into the network, right? You can see if you click on virtual machines, you don't have the tab here. And because you're admin, you can't instantiate a virtual machine, right? Only that particular user that's connected to a particular project can, right? So that's a restriction that we put in place here for admin to be able to do that. And so we're going to set up the network. So the network is the North Bridge. Available IPs you can see are huge here because again, we're using and utilizing a 16-bit subnet, right? So we have lots of IPs and floating IPs that are available for the customer here to utilize. So I don't think we'll run out of space for IPs in our back end. So when we instantiate a virtual machine, all those floating IPs will be available to them. And then if you look here and you click on Northbridge, you'll see all the various IPs that are available to you. You can scroll through and see them available that are going to be utilized or used from the floating IP. So you say, well, gee, Kevin, how do I set this up? So we simply come up to the ad network and then we go in and choose a particular network name, a bridge. We want to make sure we use bridge 1 because remember that's what we configured on our physical host as bridge 1. And then we also provide a subnet and its gateway, corresponding gateway. So pretty simple, pretty straightforward. So I want to backtrack a bit and talk about this. So let's say the use case was that I'm continuing to evolve in my Neo Cloud. And I want to break up additional subnets, or I want to bring different VLANs into the configuration to be able to air gap my environment for multi-tenant configuration. I can do so, right? And I can associate with them with a project, right? So if I click here, in this case, I would assign to a project, and I can assign to all projects, right? But if I had additional projects that I wanted to basically carve up for multi-tenant, say I have a particular project that I'm working on associated with inferencing in my enterprise for insurance-based use cases, right? And I'm doing all the inferencing and basically work on models associated with people's uh, habits when they essentially buy insurance or when they buy in the maybe you have an inferencing use case where I want to look at buying patterns associated with my widgets that I'm selling in retail. Or maybe I'm doing scientific research associated with things in the healthcare industry. Or maybe I want to take a look at people's uh, buying habits or their stock investments and that kind of thing, right? So I could break these down into various projects, right, and associate users within those projects and completely associate them with air-gapped subnets, right? And then I would, go ahead and define those VLANs, go backtrack into my physical servers that are going to be part of that Kubernetes control plane. Maybe I have specific areas of SCIF in government that I have a classified SCIF versus an unclassified SCIF, and I want to break down tenant relationships that exist for Kubernetes clusters that are imported for a classified SCIF because I'm doing maybe quantum crypto or various other types of models associated with that. So you can see here the flexibility of the control plane becomes that much more flexible as I continually bring use cases in of what I'm doing in my inferencing models and based on my LLMs. So breaking them down into various different VLANs and subnets air gaps those environments. Those IP addresses now become part of a particular project, and they are completely, truly multi-tenant. Maybe I have many use cases around. I have a conglomerate that I'm using different, a large number of different uh, companies that are part of a conglomerate, right? Things like that are maybe associated with what Koch brothers are doing with Molex as a company, and then ones associated with what they're building glass for skyscrapers, and then they have another use case around their paper mills, right? And what they're doing there. So the enterprise becomes very, very large in regards to deploying this, and we're just touching the tip of the iceberg here on various other use cases that we can utilize as far as AI is concerned. So this is going to open up a huge new world with us in the citizenship of America, right, and what we're deploying around the world for AI. So I just wanted to touch on that a little bit and get you thinking in those terms, which are going to be important. So in this case, if you've associated a particular tenant or a particular customer that you're servicing within your Neo Cloud, you can break them down into various different sort of zones as part of your air gap solution to provide within your environment. And then you would come in here and then, of course, define your bridges. So you define bridge 1, bridge 2, bridge 3, bridge 4 of those particular clusters that want to service those virtual machines, and then do that both at your top of rack switch layer to present those VLANs and those physical servers that are associated with a leaf and spine configuration, and then go to the next level, define those at the physical layer of your compute hosts that are part of that Kubernetes cluster, and then those Kubernetes clusters would be associated with a particular control plane or shard, and then you would basically carve out those appropriate subnets over here on the developer console itself, and then define your bridges. So in this case, you do define bridge 2 here, maybe bridge 3, bridge 4, and those would be different allocated subnets for those tenants that are part of your Neo Cloud construct. So that's a little bit in how we, carve this up and define those floating IPs and things like that. And of course, building that at the infrastructure is going to be important of stitching it all together and providing a total solution for your DevOps environment. All right, so enough of that. So once we've defined all of this information here within our control plane, and we'll also have an inferencing model too. We showed you in a previous video here of how you would set an application up for a one-click operation to go out and basically associate a gamma model, right? We showed you that in a previous video as part of this whole podcast of how you do that. So we're not going to touch on that today. We're really just going to test our virtual machines and see if we're successful here. So then we're going to go over to our default operation, and we're going to click on virtual machines here. And you notice the tab now opens up because we are now part of the default coming in as the local default user. If you were running LDAP and coming in as an LDAP user, you would have the same functionality as well. So if we create our VM, we're going to test this. We're going to say it's an Ubuntu Compute. You can choose the various flavors that are associated with us of this user. The admin set that up for us. Excuse me. So we're going to do 4-core, 8 GB memory. And then we're going to create a golden image here that's residing in our environment. We're going to make that basically, let's say, CentOS. And remember, we talked about this in a previous video. The container image is 11 gig, so we could give it 15 just to be safe here. And then we're going to connect to our North Bridge, which gives us access out into the internet. And that traverses through our various infrastructure, NeoCloud infrastructure we set up, we showed you in previous videos. And then we're going to also use the root password here. We're going to plug this in here. And then once we do that, we're going to substantiate or instantiate this. So it's currently provisioning. We'll wait a few moments here where it completes the provisioning. And then once that completes and is showing in a status of ready, then we'll go out and connect to the endpoint here. And then at that point, we will test our communication out to the internet itself. So as this is cooking here, I just want to navigate through a few other things here. You'll notice here that the cluster services is now showing no data. Why is this the case? Is because we're in the default local account. So we'll never see cluster services available to us. If we were to jump back to the admin account and click on cluster services here, you'll see here all the services are running as part of the North cluster or shard itself. And then if you had other use cases here where you brought in different types of Kubernetes compute, then you would basically deploy these into your environment. If you had some Gaudi servers there, or you wanted to deploy other types of GPU related servers into your use case here. You can see here we're running KubeVirt as a plugin that allows us to instantiate virtual machines. Our CSI NFS driver is pointing back to our backhaul storage for our NFS service. We're looking at other use cases there. We talked about this, about software-defined storage that's available, such as VAST and other plugins that are available through the CSI driver itself, right? So let's just peek back and see if this is completed here on our virtual machine here. So we'll go to the virtual machine here and see it's now currently running. And it's given us a creation time here. You can manipulate this the virtual machine by stopping, suspending it, issuing a reboot, editing, or of course deleting it. If you click here to that location here, we have now created a VNC console link that you can actually access. We'll just quickly go through this. You'll see here now it has been defined as an IP address appropriately in that floating subnet that we provided. And you can see here we're using a CentOS 10 image. And then it's using root access. Our memory is 8192. And we're using 4 cores, which we selected in our flavor. So if we click on the link here and let's log in as root and plug in our password here for a test to make sure that our infrastructure is intact, right? That we've configured it correctly. We can ping 8.8.8. We should be able to, and of course we can. So that means our infrastructure going completely through the various layers that we provided for building our NeoCloud infrastructure, such as the switch, the leaf switch, the top of rack switch, the netting, the firewall, and also the physical server that's participating in the Kubernetes compute that's servicing this virtual machine is there. And now let's just simply see if we can do an apt-get um, update and see if it actually goes out and communicates to the mirrors. Let's see here. Oh, I'm sorry, I'm running CentOS, so it's not Ubuntu. So we'll do a yum update. And it's communicating to the upstream mirrors and saying, hey, we found some things, packages we would like to upgrade here. So let's do so. Let's say yes here, and away it goes and starts actually loading the RPMs and updating our particular virtual machine. So we are able to do this through Windows. We are able to do this with any Linux flavor, Ubuntu, Rocky Linux. All of those cloud native images have been loaded into our NeoCloud configuration of our control plane and Kubernetes. That concludes this entire podcast on taking everything from the beginning of basically laying out a GPU tenant cloud of shards of north, south, east, and west, and right through to building the infrastructure to be successful for NeoCloud, instantiating each of those VMs, right, of those control planes, which are being serviced by a hypervisor of CentOS. Remember, each of those hypervisor, that one hypervisor is servicing both the north shard, the south shard, and east and west. Each of those shards are VMs that are hosted by a hypervisor of CentOS 10. That is we talked about that in the previous videos and how we set this entire NeoCloud up for you. My name is Kevin Culp, PM Head of Cloud Management Solutions. It's been my pleasure with sticking with you and showing you the wonderful things we're doing here at Supermicro, building our complete software stack for you, and really enlarging our software portfolio. We're no longer a hardware company. We're continuing to evolve as a tier one provider. Thanks for joining today. I bid you a farewell, and we'll see you next time.